Hello, we have here a simple series circuit. You can see here we've got a power source, one battery. We've got 1, 2, 3 meters that read current. They are ammeters. Because the circuit at the moment is broken, the current reading is 0 amps. We've also got one bulb in the circuit at the moment. Now, we've gone through this before. This is rule number 1. When the circuit becomes complete, current is the same anywhere in the circuit. That was rule number 1. If I break the circuit again, and this time put in another branch, with another bulb, and complete this branch with another ammeter, what do you think is going to happen to all those electrons as they flow around this first right hand ammeter here and reach this point here? What do you think is going to happen to those electrons? And then as they flow through the branches, what's going to happen to the electrons at this point as well, and subsequently the current readings? Now, the bulbs here are identical, so they're going to have an identical resistance. So let us link up the circuit and see what happens. Now, if we go from the battery, the positive side of the battery, you can see that the electrons, the current is flowing through this ammeter here, and the reading is 1.8 amps. You can clearly see at this point here, the electrons are splitting up. Half of them are flowing through this upper branch, and we've got half the original reading. It's 1.8 divided by 2, which is 0.9 amps, are flowing through this branch. And similarly, we have got 0.9 amps flowing through the lower branch here. At this point, on the left-hand side of this parallel circuit, because the bulbs are on parallel lines, but over here on this section you can clearly see that the current, the flow of electrons, is joining once again, and we've got the same current reading over here as at the start. This means that when current flows through a parallel circuit, the current splits between the branches, and then on the other side all the currents rejoin again. Now, we have got 2 identical bulbs here. Let's remove those bulbs for a second. Remove. Remove. And what we're going to do now is break the circuit at the top for a second, and we're going to introduce 2 resistors that have a different resistance. The first one is 10 ohms. So this is a 10 ohm resistor, this one at the top. But this second one, I'm going to double its resistance to 20 ohms. You see, what you're going to find now is the current will split between those two branches, both of which has got a resistor on it, but they are not going to split equally. They split equally with the two bulbs. Both branches on the bulbs had a current of 0.9 amps, but here it's going to be slightly different. This resistor is 20 ohms, which is double the resistance of the top resistor, which is only 10 ohms. Now, which resistor do you think the most amount of current is going to flow through? Let's find out. Right, we have a situation now where the current reading is 1.35 amps coming out of the battery, and obviously 1.35 amps going into the battery. But let's have a look here now. This top branch, we have got less resistance, so more current can flow through. 0.9 amps flows through this branch, but because this resistor has a higher resistance, it means less current flows, in fact half as much, 0.45 amps. However, 0.90 amps plus 0.45 amps always comes back to the total going out and the total amount of current flowing back in. So, rule number 4 is a parallel circuit, and the current splits between the branches of the circuit. That is rule number 4. That's the first rule for parallel circuits.